thing in colligative properties. You take a solvent like water or acetic acid, and you proceed to add a solute like salt or baking soda. And mysteriously, the properties, such as boiling point and freezing point, have changed. The preconceived 0 degrees Celsius as the freezing point for water has mysteriously changed to negative 21 degrees Celsius. Now, of course, these were just rumors and sayings spoken amongst the commoners. But tonight we shall see for ourselves whether or not these myths and legends are true. Now, my assistant Jeeves will proceed to conduct this experiment and show you the materials and procedures and whatnot of how to do so. And after he has done with the experiment and a little bit in between, you shall come back with me, and I shall explain to you the finer details of the experiment, what we expect to happen according to these myths and legends, and what is actually going on in the atomical level. So with that, I'll leave you be. Don't tear any longer. Go find Jeeves, and he will proceed to show you the experiment. This is the colligative properties experiment. This is a test to see whether or not the colligative properties are actually true, and whether or not adding a solute to a solvent really changes its boiling point and freezing point. So the materials needed for this experiment are 3 different solutes. In my case, I have baking soda, which is sodium bicarbonate. I have table sugar, which is sucrose, and I have table salt, which is sodium chloride. And I also have 3 different glasses of water, which is I have 300 grams in each. I also have 1 hillbilly stirrer, and I have, well, you need 2 thermometers, but I have 1 right now in the freezer. I have a digital one, which is right here, and I have a bimetal one that's in the freezer right now. Now, the reason I use 2 is because when you put a digital thermometer into the freezer, eventually the liquid crystal display on the thermometer will freeze, and you won't be able to get a reading from it. So I put a bimetal thermometer in there because the lower temperature will not affect the readings of the thermometer. So for this experiment, what we're going to do is we're going to take each solute and add it into each different glass of water, so they each have its own glass of water, and we're going to boil it, and we're going to freeze it 3 times, and we're going to see whether or not the boiling point and the freezing point do change compared to our standard, or our just regular glass of water that we're going to boil and freeze. So what I'm going to do is I'm going to mix each solute into theirs real quick, and I'll go ahead and do that right now. Okay, so now we're going to put our cups into the freezer. Now you see I have my bimetal thermometer in there. I'm going to put the cups into the freezer. Check the temperature. It's about -8 degrees Fahrenheit, or it's about, 8 degrees Fahrenheit. So we're gonna let those freeze, and we're gonna get the temperatures of the solutions right when they start to freeze. Now, to do this, I have used Newton's law of cooling to estimate the time it will take to reach the freezing point, the freezing temperature that it should start to freeze at. So When it reaches the 41-minute mark or the 51-minute mark, we'll come back and we'll see if it starts to crystallize and freeze, and we'll take the temperature then if it starts to freeze into a solid.